Hello, my name is Lucas Fadden from the University of Bristol, and this paper aims to understand the gap between user expectations and technology performance in the case of heat pumps. So residential heating accounts for around about 18% of all the UK's greenhouse gas emissions, so that is more than the ICT and aviation industries combined, as well as being a third larger than the agriculture industry. And heat pumps are seen as the leading solution to decarbonise heat. They could be up to 4 times as efficient as gas boilers, and they run on electricity. We observed that heat pump users are generally satisfied with their heat pump performance and expect it to be working efficiently, but in reality this efficiency is worse than expected. And so the aim of this research is to explain the perception-reality gap in heat pump performance. To do this, we collected data from 28 properties in the Bristol area. These participants were all able to pay users, which means their primary motivation was to mitigate climate change, and they weren't as concerned with costs. We conducted 21 semi-structured interviews, as well as 28 pre-audit questionnaires and 28 installation audits. The theoretical foundation for this research is the expectation confirmation theory. This posits that the expectations of users, as well as their perceptions of performance, undergo a confirmation or disconfirmation of their beliefs when they experience the actual performance of the technology. This then impacts satisfaction, as well as the perceptions of the performance impacting satisfaction. The key findings from this research is that the heat pump performance that was observed was generally poorer than the UK average, yet residents believed that they performed much better and were satisfied with their performance. This was best explained that the users rely on a best guess measure of performance, as half of them cannot view the efficiency of this system, and many do not know what level of efficiency is good. And so therefore the perceived efficiency drives their satisfaction, which explains the gap between the much poorer real performance and their self-reported performance for our study group. And so this matters as poor performance increases the carbon intensity of the heat pumps, which are exactly what these users are trying to mitigate. It also increases the demand for electricity, which not only increases the cost of running, but also impacts the resilience of the energy grid to meet demand, especially when adoption is increased. Some users use their own solar energy to power their heat pump, but this energy could otherwise be sent back into the grid. Therefore, it decreases the supply of green energy in the grid. And so this study aims to explain the gap between user expectations and technical performance and the resulting effect on user satisfaction. Visibility of performance and user education must be improved to identify underperforming heat pumps. It's worth bearing in mind that this study is only representative of able-to-pay residents, so other user groups may not be as satisfied.